So in the previous question, we have found that u of xt was written actually as 1/2 of phi of x plus vt plus phi of x minus vt. Pay attention, maybe I think that I had forgotten to correctly put the parentheses in the solution that we had written. So this is what we have found, or should have found in the previous question. And now the question is, what's the period of the solution? Okay, so for that, we remember that phi was supposed to be 2 periodic. Well, we did an odd extension of phi, and we extended that by periodicity. So phi is 2 periodic. So if I want v times my period is equal to 2, my period is simply going to be equal to 2 over v. Okay, so u is t, which is equal to 2 over v periodic. Okay, so and then the question is represent the represent. So we're doing with this sketch u for t is equal to 0, t is equal to t over 4, and t is equal to t over 8. Okay, maybe we're going to do 0, t over 8, and t over 4. All right, so for 0, well, we've sketched that many times. For t is equal to 0, it's just the initial condition, which is actually just given by that triangle function. Okay, so that's phi of x, my initial condition. Okay, then if I put t is equal to, small t is equal to 1/8 of the capital T, right? So you imagine you have your string and you plucked it. So usually it wouldn't be such an angular profile, but well, that's just a representation. That's your t is equal to 0. What's happening then? All right, so at t is equal to capital T over 8, which is actually 2 over 8 times v, so 1 over 4v. What does my function look like? According to the formula that I obtained, u of x t over 8 is then going to be given by 1/2 of phi of x plus v times 1 over 4v, so 1 over 4, plus v of x minus 1 over 4. What does these functions look like? Actually, it's just that if maybe I should have had some way to look at this correctly. All right, so let me redraw my initial condition. So that's the x axis, right? So that's the x, my initial condition. Let's say that this is the one. Okay, so that's my phi 0. Okay, what's happening if I plug, and don't forget, it's been extended by odd parity. And so it's something that actually looks like this thing, right? And so if I try to draw my phi of x minus 1 over 4 or phi of x plus over 4, well, phi of x minus 1 over 4, it's just that, well, in 0 it's just going to be 1 over 4. It's the same function actually that has just been shifted by 1 over 4. So that's what it looks like. It's not very well drawn, but I hope you get the idea. Okay, so that will be my phi of x minus 1 over 4. And if I want to do the phi of x plus 1 over 4, it's just going to be that one. Okay. Okay, and that's phi of x plus 1 over 4. And now I'm taking the average of the two. What should I get? So I'm summing my red and orange curves. So as expected, I get zeros at the boundary of my domains. I'm going to get 1 here and 1 here because I'm summing 1 and 0. 1 and 0, and here I'm doing the average. They're going to be there, so it's something that's going to look like this. Okay, so this is it actually. All right, so that's my phi of, well, that's my solution u of x t over 8, right? So you began, oh sorry, it should probably be rather, as I'm doing the average of the two, it will probably be something like this. Okay, and all right, and then so I began with my initial condition, which was this one, and then I'm getting to at t over 8 to this thing, right? And then what's happening at t over 4? At t over 4, if I do the same kind of representation, I'm going to have a shift. So my initial function was looking like this. If I'm doing a shift, it's really going to be a complete shift like this on one hand, and on the other hand, a complete shift like that. And what do you get? The average is just going to be equal to 0, right? So this is u x at t over 4. Okay, and then I guess it's going to oscillate a bit more below the axis and so on. All right, so that's the position of your string. Okay, so that's it for this exercise.